Initially, to start about the static code analysis will be there in every language. The point of going for static code analysis is, without touching the code, we should identify any potential mistakes. Then it can solve a lot of problem. So when you're writing itself, you can write a better code, right? So that's the reason for that there are many tools. So the most popular in Python are like Pylint, PyFlakes, and all these things. So there is something like Bandit and others, especially designed for SQL injection analysis. So okay, we will see. And also in terms of linting, they came up with different kinds of files, like isort, exclusively designed for imports. If the imports are there, it will ensure that anywhere if you write import, it will make in the starting, and the imports also it will ensure in a sorted order. And the imports also will come like first built in, then like installed third parties, all these things will come in that order. So like that ordering and everything it will do. So then next comes like Pipate and Autopipate. So then see, first if I can go with a small script to understand it. Generally, every code when you are writing, we will write say one Python file I wrote. In this Python file, first I am telling about the code analysis, static code analysis. So if you want to analyze, you see this is the code. So for this code, I have initially the shebang line, then the doc strings. So which are not mandatory, but you give. It's a very simple code. If I navigate to this directory, we can just execute it. It's not that difficult. If I execute like Python, so A0, I get it. There is nothing wrong, right? Very simple code. But if you want to analyze the code quality, how much good this code is, we need to go for something called as Pylint, or there is something like a Sonar Cube. So means when you go for enterprise tools, there are something called as Sonar Cube. So, but like we are not at an enterprise, so Sonar Cube means we need to install a server, all setup is needed. So Pylint is the simplest thing. If we didn't install, first we need to install it. So subsequently we can use. How we can use means Python. It is one of the module -m. Which module? Pylint. So after that, which script if you want to execute? So A0, so and so. So this will not run the code, but it will analyze the code. So what it is saying, hey, there is nothing like Pylint. So this is the first statement that you will get. So once you get it, we need to install that module. So once I install that module, you see, it will install everything. After the installation, again the same code if you run, so then it will tell, so what is the problem with this code? By seeing at this code, do you think like there is a problem? No. But you need to aware of something called as pipate. Hope you remember in the starting of the programming I told about there is something called as pipate guidelines. So what is this pipate? What are the pipate guidelines? So we have seen many a times. Like, so it will tell you, see, starting from say the indentation, how much the code indentation should be there. So 4 indentations, so spaces should be there. Then tabs are spaces. So for a blank lines, means after every function, there should be a blank line. So around every operator, there should be a blank space. So all these things are part of it. So now, if in my code, once I installed, I need to check the same, hey, whether all these things were satisfied or not. You see here, initially assume that I don't not writing any spaces around it. Okay, I'm not writing around spaces around it. I'm not writing spaces around it. So it's a very small code which I wrote. Clear the screen. If I execute it again. Now you see, first it will tell the code quality. What is the code quality saying? It is not about the spaces, but it is telling something else. Hey, it's not about the basic spaces. I am worried about something else. See, even if I replace the spaces again, if I run also, it is focusing on something else, which are of paramount importance. It found that these variables are used only once, or like directly assigned numbers and you are not manipulating further. So it is thinking it's a constant. For every constant, it expects it to be in an uppercase. So this is what. So it gave a score for us. So if you see earlier, the code was like 2.5 by 10. On a 10 band scale, it will do. So next time when you're running, it will show the previous results and the current result. If I am upgrading it in any way, so it will do the same. So I will upgrade anyhow, but instead of upgrading here, I will upgrade in like a separate script. The same thing I will take, but write in a separate script. This time I will say A1 example formatted. So the same code I will take, whatsoever I have, but now I will make in a proper way. So I understood that. So this number 1 and number 2, so means like A and B are like constants. So again, it expects not like with a single character also. So if I say like, n, say n if I give, so will it work? Or like say, this is A capital. If I write, this is B capital. And if I say like here also, capital A plus capital B, I got C. So now you see this code. So this is exactly the same, right? So A1, if I execute, you can see the same code slightly changed. So what is saying? 7.5 by 10. So it is better than the previous one. What is saying? The problem is with this thing. If the C also I changed, it will have. So the previous results and compare the current result. Now it is saying earlier it was 7.5. Now it is 10 by 10. So as per record, it is good. But if you want to further mature also, you can write. So maybe like I will comment these lines and say that, write like this. Instead of A, B, C, so and so, I am writing something matured. So if I execute again, so the previous score is already 10. So now also you mature further. So it will tell the 10 again. So this is how this particular logic executions work. So after this, in the same fashion, if I want to create one more problem, so this linting means like basically when you write itself the code, it will help you. Say what kind of issues that it can help us. So first, it can be like, the issues with the imports, issues with anything. I showed in the, Pipate guidelines. If you have an import which is not used, or like if the same import is there, multiple lines, so then also it will help us. And did you see when you're writing, so OS was like very light color, means like it is not used anywhere. So it is like the IDEs are integrated. Visual Studio Code were more closely integrated with these things. When you are installing the Python extension in VS Code, it will do these things only in the backend to help us. So, and also the order is more important. So the order is alphabetically. So O comes after S or S comes after O. So first O, next S, right? But I gave in a different order. So that also it will not allow. And also when you're writing any functions, so we should ensure that before a function definition, there should not be anything. Means at least 2 line space should be given between these two. So similarly, within the function also, did you notice the variable is not used? So if you see in this clear, I'm clearing the screen. This time I'm asking P Python, so hyphen M, so pylint B1, so and so. It will execute this entire code. Finally, we got 0 by 0. So why this is happening? Because there were too many issues. Every issue it is mentioning, see here. So re-imported as is because you imported. So similarly, so in constant variable, so unused variable, so which you have, sorry, here. So this is like a constant. So it should be in capital. That's what they say. So again, like you used unused variable. So that's what it says. And also within this, see here, this function, it is not taking anything further. So there are no doc strings. So that also it will identify. In this function, you have taken 2 arguments, but one of them is not used. So that is also point. So like that for everything. So what are the issues are there? It will do. And also this is another important thing. If you have a file, for the file, so you cannot write like big lines like this. So there is a limit on the number of characters in that line also. If you see, every time it will give the line number and at what position within that line, what is the issue, like that. So, okay, as I changed everything, if I execute again, you will understand a bit. You see, line 26, what did it say? Constant long line doesn't match the so and so. At the same time, in the second line, so one more point is that a line cannot go beyond 75 characters. Why they mentioned 75, sir? Because so in the old CPU, CRO monitors, if you remember like 5 years back, so there used to be there. So moving left and right would be very difficult. Now systems are better, but like earlier things used to be very difficult. So that's why they made that limit. Or even if you have a class, but one of the method is not used, so it will report that also. Or similarly, detecting the unreachable code means when you have a return, so this line is like empty, right? So when you did like a highlight, how it is showing? Because in the backend, there is a linter like pylint or something else. So for every editors, all these things they configured like this. So you see here, so this function is not having any return. And similarly, this is a invalid white spaces. Means whenever you are not giving white space properly. So around every operator also you need to give white space. Around every equal to anything you need to give spaces. And also, whenever you have an arguments, default argument should never be a mutable objects, right? In that case also, it will try to help us. Means without executing the code, these are trying to help us. Then how do you execute this, sir? So, okay, pylint is one thing which will give the numbering, but there are other ways. If I give like a simple execution, this is how. Whereas there is one more thing. If I execute, so like pylint, there is another one. I don't want to address it because you know every problem how to address it. So if I do like this, see here, I am taking one more module called as Autopipate. So we need to install this module also. Pip install. So -u Autopipate. Pipate hyphen user. So this is how I install this. So once this is installed, I can run it. So then what it will do? It will help me understand how to modify it further. So Pylint will just give the numbering, whether it is good, bad, ugly, like that, some kind of score. Whereas if I go for Autopipate, it will see I am getting the entire script again. Did you see this entire script? Again, it is giving. What is telling? That hey, if you use this, so it will be converted like this. Did you see the proper spacings? So did you see that before any module? Did you see here? So before any function, there should be 2 lines white spaces. So it was not there earlier. Now it is trying to give that here. Did you see? Like, so certain things it will do, but it will not change the variable names. Those kind of things it won't do because it would be very crazy if the variable names and others are changed. So certain things they won't change. The minimum spaces, minimum things what it can do. So those it will do. So, but it is not changing the original file. So there are options basically. So if I do like a difference, so means instead of just telling that what will be the new script, it will tell, so what will be the difference actually, -d file. It will tell for each of the lines, hey, this will be added, means plus plus means added. So what minus minus means removed. Okay, minus means. So every time it is doing a plus plus, means these spaces are getting added. So these spaces are getting added like that. So if we just want to overwrite on the existing file, so we can do that. But first of all, let's take a backup of this file. So how do you take a backup of this file? This is a typical Windows command, right? Sorry, so Linux command. If you want to take a backup of any file. So I have like B1. So this B1, I want to move to, say, another thing like a B1 only. So maybe instead of a B1, so I will convert to B2, B0. So I will do like sorry. So I will execute the same command so that I will get a backup of it so that I can play in any way. You see, now I got a backup. So back. Back means for Python file, this is a backup file. It is not a direct file, it will not execute. It will be like a backup file of this. Now I am executing like this. Hyphen I means in place. So if I do like a in place, now did you see the changes were in place? So you got the spaces and all these things. Wherever it can do, to some extent, it will do it. And when you're doing also, we can give more aggressively. So aggressive means like hyphen aggressive. So if you mention that aggressive, so it will do like that. So let me see this. So if I take this option, say Python -m -aggressive in place means in the same file aggressively. So I want to work on this B1 unformatted. So finally I'll get a result which is like that. So more stringently these options will be applied. So this is how these will work. But will we work like this sir in real time? No. So there are like better tools. I will tell you that also shortly. If I go for the next one. So, when you're working, so sometimes these pi linters and other linters will help us to identify any potential issues. The issues can be like pipate, means like a recommendations also. Means in the previous example, if there is no white space between the function and the comment, will it throw any error? No, right? But the code will work. It is for the betterment of the code, recommendation. At the same time, there can be potential errors also. If you see a function like this, I wrote like a print as a statement. It works in Python 2, but not in Python 3, right? So these kind of issues also it can help. If you see in this case, I am using a variable which I didn't define at all. So that is also a potential issue. And in this case, I am creating a method like this, invalid method name. So I should write like underscore, but I wrote once like this hyphen. So hyphen means like it will treat like a minus operator, and it's trying to think like that. And here I wrote a condition without writing a proper indentation. And I wrote a function with two functions. So like this. And see the same function repeated twice. Or you have used invalid arguments. So, but see here. So errors cannot be auto-fixed. This is what you need to be aware. If it can do that, there is no point of having human beings. It will write a code on its own. So when you are running, you have an issue. In the same fashion, when you do Python -m pylint. So what is that? C0. If I execute, it will say that, did you see? So whenever there is an error, the pylint also won't run. So if there is a potential error, it will stop there. And see, for every error, there is a code name in pylint. It will give that number. Next, when you're creating your own project, we will make use of these codes. Means sometimes if you are okay to go beyond 75 lines, nothing. So those kind of things if you want to avoid. So like a best practice also you want to avoid. So all these numbers will be crucial at the time. This is not that difficult. Once you Google, you will get it. But you understood. In the same fashion, Python -m autopipate, right? So will it work to automatically change this one? So it is trying to change, saying like, I gonna change like this, but it will not change the errors, right? So those won't change. So did you see this? It is coming as it is. This indentation is not changing. So these linters will be of some help only, especially when you are not designing the things properly. It can help us in a better way. Okay. So next, in the same case, we can have something else. So within the static code analysis, as I told you, within the static code analysis, one more thing I want to bring to your notice is about the various static code analysis tools. Yeah. So one more readme to add to you is that, so down the line we will see a lot of things, but just to mention to you all of them in one shot, I am writing. There are something like PyCode style, which is from Google, whenever you want to enforce. PyLint is the most common, and PyFlakes, Flake8. So these are like multiple things. Black is one other thing. So Bandit, so iSort and all these things. Sir, so can I do like every time? Should I run my code or I need to run these linters? So it's not every time comfortable, right? To run your code and linters also. So that's the reason they came up with something called as hooks. So these are something called as a hooks. Especially if you go to the Git hooks, means when you're doing a Git push, right? So before, these are like various hooks called as pre-commit, prepare commit, so commit message, so post commit. These are all different events actually in Git. So not just GitHub, okay? It can be Bitbucket or it can be VSTS, means Azure DevOps, or anything. The process is same. Every time when you push some code to the repository, these are all the events which can happen. You can hook your things to a particular thing. So the most common among them is pre-commit hooks. These pre-commit hooks basically will help to do these kind of things. Means whenever you have something, so can open a file. Okay, so copy path. Okay, you see now, this is like the total commit pipeline. So whenever you are writing any code, where you want to format better. So first, initially, your file changes will be there. You will do a git add, then it will do a staging, then you do a commit. So after committing, so you want it to be checked. So these are called as pre-commit hooks. So means when you are committing, if it checks for these kind of things, like black for the formatter, flake for checkers, like different kinds of things you add. If everything is good, then you want to push your code. Else you don't want to push. Because if it is going to the commit and the CI/CD pipeline is executing, and for even if you write like a small change also, if the build is failed, so obviously build process also takes some time. It is costly enough. To avoid this problem, they told to rely on something called as pre-commit hooks. So primarily this hook, what they do means they will help us to work on this. Say like I can pull some pre-commit hooks for you. Okay, so if I go, yeah, so how the pre-commit hooks works is we need to have a new file called as pre-commit hooks. So generally at the repository level, we write like pre-commit so hooks dot YAML file. So YAML file. So we need to write this YAML file to help ourselves. So whenever we are working, these are like very much useful. So yeah, yes. Okay, so okay. So not hooks, like config file we need to write. Once we write this config file, within that config file, we need to write all the settings. So basically pre-commit is one of the module, like a third party, like Autopipate, etc. We need to first install it. So how do you install? The process is very simple. So pip install pre-commit. If I do like a pre-commit, it will install it. Once it is installed, we can use it. So pre-commit, like pre-commit. So run -a means for all files you are saying. So when it is running, it is saying that, hey, I'm missing something called as this pre-commit YAML file. So what it is saying this time? So if it is not there, it will tell that. As it is there, it is saying invalid configuration. But if I add some configuration, then it will work with that. So if I execute right now, for the entire code, what are we developed, it is executing. And it will tell what all things we need to do. So whenever next time when I'm pushing the code, it will automatically check for that. So what all things see here? Though I wrote the code perfectly, there are certain things which is like, in this JSON file, it is saying the JSON file is not proper. See, pretty much. So did you see that? It will auto change it. If I go to this, navigate to this file. So you can notice that if I navigate, earlier how this file used to be there in a single line. So it was auto formatted. Who did these things? So here in the pre-commit hooks, we have for everything. And see, first options is that in every pre-commit hook, we can specify what language. So means like Python, right? So what is the version that you want to fix with? So what is the like fail fast means when it is executing, there are some which are converters, like mirror prettier. Prettier is something which will convert. So means format actually. If the JSON is there, it is trying to do in a very proper format, right? That is like pretty printing. So that kind of things also will be done. Sometimes there are upgraders. If there is any new version of Python for the particular things, it will upgrade it. When we have requirements txt, I will tell that afterwards. At the same time, we have isort, I told, right? Sorting the dependencies, so imports. At the same time, we have different webhooks for different purposes. So like pre-commit itself is like one of the module. So they came up with certain things. You can see that. So there were different modules for different purposes. At the same time, initially when the concept of pre-commit hook came to picture, so there is a new repository called as pre-commit. So they came with like some predefined hooks. Like, if you want to check for a largest files, whenever you are working with data science MLs, certain times you will have very large file. You don't want to upload all the files, right? When if the files are big enough, so it will raise a alarm saying like, hey, the file size is greater than 1 MB or 10 MB or something. So similarly, if you want to check the ASTs, or if you want to exclude any file, I wrote the code like this. Means whenever I wrote like this file will be ignored. So there is something like Python 2 to 3 conversion where I have Python 2 code. In fact, generally it should throw an error. But if I did an exclusion like this, then it will ignore that file. Similarly, if I want to say the case conflicts, so camel cases and others, if you have a mixed of all those cases in a single program, it will show that. Means in the previous case, what you have seen, the Pylint and others are trying to do the small changes like regular pipate guidelines. But if there are errors, it will throw, right? So these commits, what will do, if they can, for the basic converters are there, they will convert. So other things, they will stop. If when they are doing all these checks, so here I wrote like fail fast. This concept of fail fast means we have like say 10 tests. Each test it is executing, somewhere it failed. It should stop there itself, or like it should execute all the other tests also, such that together you will address. So that's what it will tell. Fail fast false means it will, though someone fails, it will execute all of them, and you will see the results finally. So if I say fail fast true, if something is failed, it will stop there itself. As a developer, it would be very irking to go for everything. Sometimes the same place, 2, 3 issues may be there. So all those things. And also see here how things were happening. So sometimes you are seeing that indentation errors are there. So whenever there is an indentation error, it is throwing there. And it is saying for some things, rewriting means it modified it. So sometimes it is saying what? So you see here, end of file, fix end of file means for every file, at the end, there should be an empty line. So for these files, all of them, there is no empty line after the file. And similarly, so mixed line ending. So sometimes you have ended somewhere. So all of that, if there is at the end of the line, there is a white space extra. So all those things. And if there is any trailing white space, which I told right now, it will fix them. So for every file, it has fixed something or the other. So using black for like reformatting. Black is for reformatting. So for everything. So black Jupyter notebooks, especially it works only on Jupyter notebooks. You see, only .ipynb files. So within our code, these many changes are there. If I do like a git status now, that's where you will see easily. So if I say git status, see how many file changes were there. As this is, we are applying for the first time. Subsequently, it will not do that much. So if everything changes, then fine. So again, if you do like a pre-commit, so run -a. So this is not the correct. Once you made a changes, you need to know what all changes you want to make. You need to stage them. So then it will work on them. So why it is showing again these errors? Because for some files, it found it again. So when, let's say this is there, PyUpgrade, it found an issue. Sometimes issue can be there in the module itself. If you can observe carefully, indentation error. So where it is coming? Py token is, this is not our code. This is not our code. This is not our code. This entirely is not our code. So there is a problem with PyUpgrade itself. So then you can reduce that version number. Something issue with the PyUpgrade itself. Maybe like you can take a 3.0 or something else, and you can work on it. So at the same time, If you found some issues, you know code, you can address that. You see, even AWS credentials, all of them I wrote. So fine, leaving it. So every time when you do a pilot, so first we need to add the changes. If I do a git add star, means all directories, all files will be staged. See, everything was staged. So everything it is changing. See, in the current directory. If I want in all directories, everything should be changed. I will go one level above. So 2 levels above. If I do like a git add star, so be very careful. We generally should not use this, because if you do like this, it will add everything in and under this directory. So if I go like one more level above, if I say pwd, the current working directory is like this. So if I go like this and say git status, now everything is there. If I do a git add star, you see everything came green. So because of I added it. Next, if you see further git status, you see, and one more important point is every time you make a changes to your pre-commit hook, first we need to upgrade it, push it. So it means like you need to stage it. Only then we need to apply the pre-commit hooks. Pre-commit run -a. So means like pre-commit run. So for that thing. So now it is syncing again. So previously, how many changes you make? All the changes I staged it. Now on the staged results, it will check again. So the process is very simple. First, you need to write this one. So, and also some of them I don't want at this stage. I commented it. So if I want a different version, I can go with it. Also for the auto pre-commit hooks also, you can do auto upgrade to upgrade the versions. So like that, these are all the static code analysis. Without even executing the code, you are addressing the problem. So that is very great, right? So that is really helpful. It's saying like it's still executing. So on top of it, it is checking the entire directory. So for any issues potential. So like that it will go. Next, going further. So for the next thing that we have is code analysis. What is this code analysis? How it can help me? So in this particular case, the first one is like profiling. Profiling code. Code profiling. So generally we do code profiling whenever we want. See, like it is still executing. Yeah, it gave some results. For some of the files, it found like there is an issue. So we need to avoid that files. So first, every time when the result is coming, we need to check why it came, from whom it came. Prettier, it found certain things are not good and it auto formatted. So this prettier, for every time line will come. Then pi upgrade, some issues came. What are these things? It has nothing to do with ours. So there is a problem with pi upgrade. I am commenting this one. So next, coming back. So next one is like isort. Isort means if the imports are not in a sorted order, it will automatically upgrade it. So where it found somewhere here in this file. Okay, fine. So then like, so check ISTs, where it failed. So in this re.fail. So in this particular program, it's saying that it was failed. So every RSTs. So like this. Similarly, here there is a print statement. I don't want this file to be checked. So then whichever file you don't want to check, so we need to write here in the webhook. So here in the, so for which webhook, what you are checking. So here, so it failed for which one? If I can observe carefully. Yeah. So this was failed, this file. So for what? Check Python IST. So check Python IST is there, right? AST, sorry. AST, check AST. I want to exclude this file. So I can write that file name. So the exact directory path. And observe, so the path should be like a Linux. Don't write a Windows path. Means slash should be like this. Then next time when execute, it will ignore. So I don't want to focus more on it. The same process will execute. If I, so now I changed it, right? So git add dot pre-commit hook. Then again, we need to do like a pre-commit. So run -a. So that's how like, Oh, not only that, the remaining file changes also you want to do, right? Git status if you do. So some files were like still modified. You want all git stat all. So then you can do like a pre-commit hook, run. So leave it. So that was done. Next, as I told, next one is profiling. So this section is dealing with the code and how the code is there, how to analyze the code and others. To work first on this one, first we need to work on the usage. So this is something called a C profiler. So basically, profiler name is called as C profiler. So means earlier there used to be profiler and C profiler in Python 2. So the Python 2, the C profiler was taken as this. Why it is called C profiler, I don't know. So maybe because like they have worked on it. So that's why they gave it. So to work on this module, open with Notepad. So whenever you have some cells to upgrade, so like this we can do. So when you copy, it will open it like that. Okay. Yeah. So first we need to select the kernel. I took Witwork. So first it should have this C profiler. If I execute it first, it will throw an error if it is not installed. Else if it works perfect. What is this module about? This module is about the very basic modules. It will have only three functionalities here: label, main, run, run ctx. So main, run and run ctx are the two things which are useful. If you have anything, we can run it. So it will pass to eval function and it will execute. See, in this case, I have a addition. So when you're doing 20 and so, how many calls were happening? It is saying totally 3 calls were done. So means 0.0 means a very small fraction of seconds. So ordered by standard name. So means, see here, number of calls, 3 calls were done. How? First it created a string. So that built-in methods execute. Then within that profiler to get the results for us. So every time this line will execute, only then, right, we can get the results. So in this, if you notice, the first one is n calls, means it will show number of calls made. And it total time means time taken by the given function, how much time it took for each of the functions. So, and like per call, so total calls, total time by number of calls. So that will be the per call things. So, and like cumulative time for each time, so totally it took 10 seconds. So first functionality it took like 2 seconds. Next functionality took 2 seconds. Then it will say cumulative as 4 seconds. So means like next, for the next 2 seconds, what happened? Like in a timeline, if you want to make, this is useful. So you see in this example, so this is also a string. Within that I have a logic. So within that, see, even if you write like this, it will do indentation error also, because it is executing with eval. So you see here, if I say result equal to 0, so result like append, it is saying totally 12 functions executed. Why so? So 9 means like 9 loops should execute, right? But why 12? So that's what you see. See, first 9 times for the append method happened, because 9 times in the for loop it goes 9 times append. But the remaining are for the first starting. First getting the string, that is the first method. In that built-in execute. These two things you saw earlier also. And lastly, the profiler also you saw. These three C calls are minimum. So, but remaining are like depending upon the situation. In this case, this one extra done. And in this case here, I am writing all in a single comprehension. Comprehension means no call of method, right? So, but see how it happens. Again, string here. So string and this time list comprehension. So comprehension it is executing. Then it is going for execute again. Then profiler. So means this executor, profiler, and string, these are like common, right, everywhere. So that's why to say, whenever you have something like a single line logic, instead of going for a for loop, it's better to go for a comprehension. Instead of 12 calls, it will execute in just 4 calls. So this is one conclusion. And similarly, if I go here, see here, I am directly doing a conversion from a range of 9 to list, not even iterating using a comprehension. So in this case, instead of 4 calls, it will just execute in 3 calls. what is this crazy, sir? Yes, of course, this is much more faster. And also this time I added two extra options. Till now we are not using, but there is something called as file name. Means the results what you are showing down, you can even write to a file also. So, but that file is not useful directly for us. It will be useful by a profiler tools. So there are like some third-party profiling tools like SonarCube, or like there are other tools also. They will make use of this profiled results to better visualize. And similarly, if I go for one more example, this time I have written a function like create an array. So it will take these values, 40,000 values. So, and it will execute for all. So maybe like I will write for every three. So we can write like this, right? Oh, so it's much big, 4 lakhs. So as you see here, and it is a small statement also. These two functions, it is executing within this main. So instead of writing the entire code within a single function, so single like a string, we can write individually. And what is the main function you want to execute? That only pass like a string. So this is also a beautiful way. So this is better, right, compared to previous, because we cannot write all code in a, so like this. In real time, this will be useful. You see now, totally these many calls were done. How much time? It took some time. So very basic you took for the main to execute, then for create array function, then for print function. Then after that, the string module, which is, from then onwards to work on the other pipelines. So what all things it worked. For each of them, how many calls it were done. So in fact, it is very big enough. So if you click on this text editor, you can see a list. So among all operations, which one took more time? So this one. So it took like 40,000, so it means 4 lakh operations and this much time. So overall, you can understand, right, which took more time. So like that. So when you understood your code, you only can better mature your code. And similarly, when I'm doing, I can do like a sort equal to true. So sort equal to true means the same result I got. So it didn't do the sorting, because by default sorting will happen based upon all these three. But if you want the sorting to be specific based upon something, we should specify that. So individually by one. If I give like n calls, it is sorting. And observe, sorting definitely will be descending order. No one expects a sorting to be ascending order, right? Do you want someone want to know which is taking small time? No, right? Everyone, when you want to do code optimization, you want to know the largest thing. So don't ask that question. But like sorting will happen every time descending order. So you give the parameter, based upon that it will execute. Now a small assignment for you is that I did based upon n calls. Now you do based upon a 2 columns. I did with a single column, right? Now you try with the 2 columns. That's the assignment. Similarly, the result I am getting the output like this. But if you want the result to be placed in some kind of file, you can write like this profile.txt. But the point is that this is not useful for us. So whenever you have a third-party tools for your code profiling, so for that it will take like an input. So when I opened it, did you understand what happened? No. At least this is visible, so we can understand. This is not at all understandable. So, but this is for a different purpose. If you open a text editor also, you can see it. It makes no sense for a naked eye. So fine. Next, so when you're profiling, so if you want to profile multiple functions, till now you have one function, right? So you have like multiple functions. Then how to profile it? And on top, this function is taking some inputs also. Now you see here, use range function of range of 10,000. I gave it. So when I gave 10,000, it took like this much time for doing it. So it worked on it like this. Any doubt till now?
No.
Sure, fine. So next, so like this, if I go further to the next function also, it is executing. But what if you want, so it to execute for both functions together at one shot? So like this, you can do is comma separated. If I do comma separated, all the executions will happen. And it will not show individual results. See, in the two functions, both functions has like append operation. So in the first function when executed, it told append this much time. Second function append this much time, because same number of loops. But when I executed both of them together, Overall results it is giving append took this much time. But sir, what if I want to compare these two functions? That's where you need to use run ctx. If I use like this, then it will execute both the results, but it will place separately. Then it's easy for us to analyze individual results. So fine. So if you want to profile like line by line results rather than this, you can go for another example. So line by line profiling means this is what you use in real time most. So I created the same logic and I want to execute. First I do a C profiler and pstat. So then first I do the profiler.enable. So this profiler, once I enabled, it can be like one function, 10 functions, any number of functions. I can write within it instead of passing like a string and into it. So I can execute any number of statements. After my work is done, I can do a disable. So between the start and the enable and disable, whatever you wrote, it will do the profiling only for that. So this is much good. And what are the results are there? If you want to analyze that results, we can pass to this. And if you see the results, this is more clear. So line by execution. This is a better way of profiling in real time. This is called as line by line profiling. So there are like different profiling examples. And similarly, if you want to profile with memory, so there is something called as memory profiler, but this module need to be installed. So like memory profiler. So once you installed, you can do it. It will tell in terms of memory how much usage and all these things done. So with this, like, so the basic things were done. Next is into the code quality in terms of unit testing, py testing. So finally, if you see, for each of the repositories I mentioned, most of the errors are coming only in this thing, the static code analysis. I showed the errors also. This file is prone to errors. We are not working on a real project. We are working on tutorial. So then obviously there are certain things which we need to handle it. So we want to ignore that. Overall, in all the tests, if you want to ignore a particular directory, you can give that exclude. But if you want to ignore at the particular repository level, you see here there are different repositories. So apart from the different repositories, we have overall hooks also. Means hooks and repositories, the difference is like these are all separate projects and these are all part of this same project. So you can just use anything, you can get it. Sometimes you will have print statements. You don't want the print statements in the product, or like you don't want certain amount of credentials or like anything. All of them you can place it. You see in this particular folder, so there is debug statements, means IPDB, PDB and all these things. Generally in production code we should not have. But as we are in the development, obviously we will have it. So to exclude a particular directory, I did like this. Or to exclude a particular file, I have done like this. But in overall all the tests, if you want to exclude something, you can write here. If you have multiple things like that, you can do a pipe separated. So this is all working with regular expressions, right? It is starting with this one and ending with this. So what I wrote within it, dot star, means anything within it, any file name or subdirectory like that. So everything it will have. And even in the isort also, it can have like different profiles. So whether you want to check only or if you want to format also, that you are mentioning here. So for everything, there will be a versions also. So finally, I got a lot of errors. But this time when I ran, all the things were successful. No more errors. Means pre-commit hooks are perfect. Now if I do a commit, the code will go directly. So after making this commit, so as we are in a Git branch, we can click here. So what is the Git current status? Git status. Git status. See, I was in branch 41. So now if I do, so git commit, already the things were git commit -m. So class 41. So code quality, right? Code quality. If I do a commit, the code should go. Earlier, if there were errors, right? So when there were errors, if you try to do a commit, it will not go. So in the Git lifecycle process, we know first we write a file, then we do a git add to stage it, then we do a git commit. But this pre-commit hook adds exactly before the commit. If there were any issues within the pre-commit, it will not allow you to commit the code itself. Now, don't you think everyone who is writing the code will follow all the standards automatically? The code which is coming to the repository will be clean. So that is what is the expectation of pre-commit hooks. So once it is committed, it's up to us when to push. So if you want to do like a git push origin, so what is this class41? If I do, so this will go. So commit is the main thing. After that, push is up to us. So whenever you want to push, leaving it aside, coming back to here. So in the static code analysis, so after this in the code quality, we have seen the profile. In the profile section, so we have seen about the memory profiling. In the memory profiling, so it will take, but memory profiling in a Jupyter notebook, it is like too crazy now. So better to run like a separate scripts. I wrote separately. So in the memory profiler, so the first thing first is like we need to install this module called as memory profiler. So memory profiler, and it has a dependency called as PS util. Earlier, you remember we worked on process related analysis. This memory profiler will do that. So that's why it has a dependency on this. If this module is not installed, we need to install it. Then we need to work on this profiler to get things done. You see, I wrote a small code here. I have multiple functions. Function 1, which is executing something, and function 2, which is like memory intense, more memory intense. So memory intense, memory intense. You see, if you have some functions, you are regularly executing those functions. The moment I placed a memory profiler or profile, I am adding the decorator. The moment I add a decorator, see, for all the functions, I add a decorator. Here, in specifically, I gave a precision equal to 4. Now, if you see, if I execute, so if I navigate to this directory, Python, b so and so. It is like an ordinary function execution. So it is saying like memory profiler is not installed. You see like pip install memory profiler and ps util I am doing. So ps util. So because that were needed for me, so I am doing it. It is like a sub dependency. You see how it is doing? It is doing a wheel file. Did you see when we created a module also we created a wheel file? So and it is saying what? Cached using cached memory profiler. Sometime else, so I maybe download it. So it will have a local cache basically. From there it is getting and installing. Now after installing, I'm running my program. So for every function, I added this thing. Now did you see? So if you want more clean, I execute it again. You see for every function it is saying. So first one is like function 1. So from what line it is executing? See here, from line 10 to line 14. Line 10 to line 14 exactly. This is our code, right? Each line, how much memory it took for execution. Overall, it took like 47 MIB. So MB is different from MIB, right? So megabytes, so bytes. So it is telling about the memory usage. So memory usage is different from memory occupation, right? Fine. Next. So wherever I placed a profiler for that function or for that method or for that class, it will execute. So you see here for this execution, overall it took this much time. Where it took more time? So whenever for the smaller one, how much it took? For the larger one, how much it took? So all those things it is computing. So finally it is deleting, right? During the delete operation, how much memory is getting reduced? Minus means reduced. So overall, how much it is? Maybe for the smallest thing, so I should have done like some 10. So largest thing I should have done big. So if I execute again, you can notice that now it will take very less time. So obviously, so for the smaller one, it will take like how much? So 47 MB. So the moment it took. Now, did you see that for every function, minimum it is like 47 MIB, 47 MIB? For like minimum for every function, we need to start and doing it. So subsequently, it is trying to increase or decrease. So based upon the values. Now I did like this. Now try, so for like assignment. So try for a function. So method in a class and entire class. So these two you try on your own. So the same like implementation, you need to write this profile, this thing on the top. And did you also notice that here I wrote for the last one, like precision is equal to 4, means the result when it is getting, so I'm asking post decimal 4 digits. So like that, I'm asking in terms of memory consumption and so and so. At the same time, so if I go further into the C profiler, so we can also do like in the code profiling. So we have seen different results. So let me see again. So this time you see here, generally, when you have a big values of a range will not generate all the values, but it will do like this. So it's a very big, large numbers, right? It is generating. Finally, it will convert to a list. In this list, if you want to analyze for some value, so how much it gonna take? Obviously, it will take more time, right? So it is taking, see here. So in terms of execution, but at the same time, if the same values are like in a set, how much time it will take? It would be very less. Did you observe overall how much time it took? It took like 0.139 seconds and 0.000. Why? Because when you are doing a in operation, it will search, right? So for a list, if you want to search for any value, it is O of n. Means worst case, if you have 10 values, I need to check for all the 10 values to check whatever I have is correct or not. Whereas in a set, it is like O of 1. What do you mean by O of 1 means? Each one will treat like a separate hash. Means each one will be very unique. That's why in sets you don't have duplicates. So that's why in sets you don't have a unhashable values. So that's the reason. So if you have a values in a set, it's easy to read fastly. Set and dictionary are like most optimized for reads. But whenever you are writing, so these are not that good enough. So whenever you are doing a write, say like, see here. So if I take the other examples, okay, you see this time. So for creation itself, I'm asking. Earlier for creation, I'm not asking. Now for creation itself, I'm asking. So which one will take more time? Which one will take less time? So for creation, the last two, if you observe, which is taking more time. So if you can carefully observe, so list is taking like just 0.5 seconds, 0.5 something seconds, which is like very much so small. Whereas for this one, how much it is taking? Set, it will take like large time because so it need to first create a hash of each one, compare whether there were duplicates and store unique values, all these things, right? That's the reason. So the conclusion is like whenever you have like more reads, so or more writes, we should go for a something. So the note is that so when we have more reads, go for set or a ticked. So when we have like more writes, means more time we are writing than like reading. So then, so if you want like a sequence or so and so, go for a list, tuple, or like numpy array. Next you will learn about numpy array. So these are like good. So this is what about the node thing. Now for the assignment for you is like, let's walk through with these things with other data types also. You do your own evaluations and understand it. Next, you understood about this membership check, how it is taking, how much time it is taking. So let's first create one values. Domain is equal to range of 50,000. You know, right? Range, in fact, creates a state that it should generate the values, but it will not execute, right? Now, let's see this. Once this global variable, I am using this global value. I am converting that inside it to a list and I am looping over it and each time checking whether that I is present in this list or not. It is a crazy thing. So you are looping to each of them and getting each value and again checking whether it is present in it or not. So simple example for doing some kind of time consuming work. You see, if I execute it, as I place it C profiler directly inside, so I can use like C profiler at run also, or you can create a profiler object separately and do also. So it ran for like this 50,000 values. Each of the value it is checking. See, generating will not take much time. So if condition will not take much time, but generally assertions will take much time. That's why unit testing is not there in production. Thank God. You see how much time it's taking? 19.5 seconds just for like 50,000. Earlier, see, so for these much values also, how much time it took for creating. But see here, assertions. Assertions are the most important thing, which will take a lot amount of time. So that's why see here, so as you placed like that, it is taking more time. At the same time, so doing the same thing with a set. So if I can repeat the same with the set. First converting to a set and then rechecking on the same thing. So like this, first time converting to a list and checking the results. So in everything, checking for a set and so and so. You can notice the difference between these. So with this, we will get a clarity, like which is taking more time for like checking also. Obviously, here also the same thing, right? When you want to check for something, O of n. So here also, when you want to check, it is like just O of 1. That's why see here, overall, it took like this much number of seconds. Same four calls, but this much time. So for the same core four calls, how much time it took? So it took like, so 20.37 seconds. So whereas this one took like, is there any comparison at all when you compare with the set? So that's a thing that I want to bring to your notice. So that's where you need to understand where to use what variable like that. Next, after these things, we need to know about this. There is something called as OBJ graph. So OBJ graph, what it actually does, if we can work on it, say, if I go for the DAR of this OBJ graph, you will understand that. What is it about? So Python A example. So this is not installed. So we need to install it. So pip install -u. This is like standard instruction. So I will take it. So maybe like we can write. What is this OBJ graph? How it can help us? There are like multiple use cases for it, to be precise. So if I can touch base on it first. Okay. So first, if I say like some values, if I have, okay. See this example, it has good number of attributes, and especially see here a lot of the other modules we have seen collections and others are there. But primarily, so you can ignore those other modules like so collections, this subprocessor, all these things are there because this module when they created itself they are using it. So first use case, if I say I have one thing called as x equal to 1 2 3. So this x equal to 1 2 3, I want to see the graph for it. So I can create a graph and do it. If you can observe carefully, x is like this, and this x is also part of this another y. So like that we have a graph. So I am telling that obj.show graphs of x. So like this result. Now if I execute the same thing again, you can see that. So do nothing. So image rendered not found. It will show like some kind of back referencing basically. Why it's not showing? Okay. It is saying that so it was written to send this directory. Yeah. So did you see now? This is a graph which is getting generated. So this is again useful in the Sonar Cube. So when you go to your real world, so you will see about these usages there. Basically, all this setup will be done in the CI/CD process itself. So I am explaining for you clearly that like how it will be generated, where it will be generated. But this is what you need to be aware of. So primarily, this tells about the back reference tracking. So for any object, how it is created. So the objects, where location it is created, all the information it is showing. So for every object. So it may not be that understandable, but whenever you have like large things, it will be really helpful. So this is all about the backtracking, okay, back reference tracking. So next thing is about, in this OBJ graph, there is something like commonly useful things. If I say the commonly useful things, so most common types basically. So for each of the type, functions, tuples, dictionary, wrappers, what are all the types are there, basic, and their usages and all this information you'll see. So in this particularly, if I go for one of the function, say like some leaky function, if I want to see how much time it will taking and all this information, I can go, say like, see here. So I have my leaky function. So maybe like, so I took like a, so default as a, so mutable object or something. I can show like a show growth. So how much time it took the growth, like what is that function, and I can execute. So means first to get the counts I can do, then I can execute and I can stop the execution. Overall, it will give me the total of how much time it took. So when I asked like the common type of function, so most common types, till how what are is there, the basic things it gave. But when my function was executed, anything new were added, it is doing. So here you didn't add a new function, new tuple or something. So plus plus plus, the same value is getting. But if you go further, you can see it. So like that, there are multiple other tools. One more example for this kind of analysis is about the disassembler. Disassembler means like not every time you use it. So in fact, there is a built-in tool also to analyze this. So, but like if I can go on, there is something called as a dis module. If you install Python, by default, it will come. If I can go ahead and show this one. So Python disassembler, it's a built-in thing. What it actually tells is that the code, the Python code we are writing, which will be converted to the C language. C language will convert to the assembly level language, right? Then that's how it executes on the machine. So when converted to the assembly level language, how the code will be there, that I want to show you. So this code, if I have like a hello world, print hello world. So this is how it is working for any code. And similarly, if you for the same code, if you are adding some more complexity, so then how it would be? Say like, if I take one more example. So I'm writing like empty print so that, so you will get a difference. So CLS and so and so. This time see here, I have just a hello world, but this time I have three statements within it. So how it is working, see here. So I have three statements. For each of the statement, all these things are happening. We generally think like one print statement, but for one print statement, this much activity will happen. It is loading the globals, constants, all these things it is doing. It is onto the analysis. But if you want to do the byte analysis of these results, so that's where we can go for. So there is something called as this.bytecode_of. If you do this.bytecode_of, it will give the bytecode instructions and it will give all the bytecodes instructions individually. So don't you see that from the starting, what are all bytecode results are there? This bytecode, so so these are like way procs, right? In the assembly level language, we call procs. So those procs it is showing individually. If you want to analyze, you can go ahead with it. So this is one thing. At the same time, we have a so disassembler tool also. So in fact, anything you can write there also and execute. So if I can execute it, you see now, this is like we have feed to conversion. So each line also it will focus. If you highlight, it will show. And in this bytecode is different for different versions slightly. So that changes also it is showing to you. So it is taking a moment for loading. So how it was changed. So that's the reason nowadays it is a bit faster because they are doing something in the backend. I don't know about this. So assembly level language. But this is how you can see. This dot hyphen this dot come. This is the disassembler we have. So whenever you want to know the best practices or like which one is taking more time, so and one assignment for you in the disassembler is check which one is taking more time. So one assignment for you is like, so whenever you have a plus equal to, So whether compound operators are beneficial compared to the others. Means we can do with the compound operations also, and without compound operations also we can execute something. So what's the advantage you're gonna get if you go to the compound operations? So then you will see, whenever you are doing a compound operations, will it's taking like less amount of memory and others, that's we can see. So next thing, yeah. So there is one more tool called as inspector, basically code inspection. So there is a tool called as inspector. So inspect, this also comes built in. So if you want to know like the print of dir of this inspect, it will also give. So these are all like analysis tools. Earlier we have seen static analysis tools. These are like direct analysis. These will touch the code and it will work. It need to directly execute this code, right? So Python inspecting code. If you can observe that, you see, it is taking, it has a good number of attributes. In fact, you can work on coroutines and a lot of things are there. So at the same time, this inspect comes with something called as a stack. Inspect.stack. So within this stack, what all things we can do, it will tell. You see? So it is giving the current stack of this thing. What are these informations? If you can observe carefully, each of the information, did you see that this is like a single object you have? Within that object, if I can decipher, you can understand this. You see the each frame. In each frame, if you see, so this is like frame information. It is telling about the frame. So what is the file? So where it is executed and all this information. If you see, this is the file. So where this file, it is executing our file only. And what is the line? At what line? Line 6 it is. So because there only we printed. So what is the code module? So what is the file name? So which file, what file name executed? The same thing. The code object further it is giving. So all the information about this particular logic. So whenever you want to work. And similarly, so whenever you were asking about the file, you know, right? Underscore and underscore file, it will give the file information. So this current file. So along with the current file, this current file related frames and others it is giving. And if you want to further detailed execute, you have like the frame line. So line number. So what kind of line number it is executing. So each line, did you see that? When I'm executing in line 23, I got line 23. When I'm executing at line 24, I got line 24. So if you want to be precise on when you're executing something, we can ask it. So maybe like say one more example, if I can go on. So you see this example, I am asking the DAR of dot stack of 0th value within this. So within that means what our object is there, for that what attributes it has. So line number, frame number, and all this information it is giving. And similarly, if you want like properly, so with all those details together, so I can give like one more example. If you can observe carefully. So within this, I'm asking the current frame. Anywhere, if you are asking the current frame, for that I'm asking a f back. So, and I'm asking the previous frame for it. Every time I'm getting the previous frame and like inspecting and passing the previous frame. When you pass a frame, you will get all this information. That's what we got in the top, like file name, line number, function name, all those informations. So all those informations only you get here also. So when you execute, see here, all the information you got. So this is all about like inspecting code. So sir, is it also mandatory? No. As part of your CI/CD process, you will do this analysis sometimes when needed. So the last point, but not the least, which is very much critical, is about so Python 2 to 3 conversions. Whenever you have a code, so at this moment you definitely won't have, but be aware that if you have like a old Python code to convert, so in old Python code, people used to use raw script, okay? Then like if there is an exceptions, they used to do like this. And the print is like a statements. And even if they want numbers also, numbers is equal to X range they used to use. If I say X range of 10, that's how it used to work. And like there were many things in Python too, which you don't even need to know. But this is one thing. But if you want to convert this, there are multiple ways. So there is like Python 223, lib223, which will come by default. If you say like Python -m lib223, you will notice that. So it is a like at least one argument it takes. Anytime any module, if you want to know how to use -h, it will give the list of attributes like what all things to do. Now, if this file, if I want to convert Python -m, so lib223, so 223. So what are the script I have? Python 223.x example. If I just execute, so unlike the previous things, it will just execute and tell that what lines, what will be changed. So original refactored. So wherever minus is there, it is going. So it is saying X range is converting to range. So raw input, wherever you have, it will convert to input. So it is saying input, right? And print statement, wherever it is a statement, it is converting to print as a function. So like that. But it is not changing your original object. So if you just want to know the differences, so we need to remove the hyphen. So if you want to see the results also in place, then you have to go. Now we see, if I go for this example above, but with a -w, means I want in place changes. Now if you see, did you see the code was changed? Raw input was changed to input, X range was changed to range, print statement was changed to like this. Earlier exception comma used to be there, now exception as became, right? And at the same time, old code is not good. It created a backup file. So for like the backup file. So whenever you have a project like folder or something, you give the entire folder name. If I have some folder name, so that folder name I can give. So such that it will check for the entire folder. So entire folder, it will convert like that. So -w. So if you have a folder module, it will do for entire. This is how you convert from Python 223 and others. It's a dynamic type. So Python is a dynamic type language. Means like whenever you create an object, you are not initially giving the whether it is a integer or a float or something. You just give like what are the value you have, and we need to generate. So due to that, most of the issues are coming. So if you see in the Python, the most important issues are like runtime issues. Runtime issues are mostly like, hey, you are trying to add a integer to a none. So those kind of issues. So these kind of issues were not there in static type languages like Java or Go language, etc. Because when you're writing itself, they will ensure that all the data types will be perfect. So in Python, if you want to do that kind of analysis, they created some modules to make the dynamic type language also kind of like static. It's like, just imagine like for JavaScript, we have TypeScript. So like that for Python, to make it type sensitive, so we have these modules. So the most famous among them is MyPy. So which the official of Python, which was created by the Buddha Van Rossum. At the same time, other organizations like PyType, Pyr, so Pyrite, different things came. They came with like conditional constraints. Means sometimes a function needs a value, which is optional. Or we can have like multiple data types. So, or we have like a specific data type or a new kind of data type. So all those things to add, they added some conditional things also. So first, to understand more about this typing and working, first let's say a module I'm going. So if I go for this module called as typing, so let's see how I work. First, I need to install this module whenever I want to use it. So if I go for like the MyPyLang site also, you can understand. So what are the different things that they are supporting and what we as an individual need to do. So for all those things, they gave the information. So, so like initially the code is like this before and after typing the static typing type. So it will be like this. Means what you are trying to say, hey, I have an integer. I am passing like int only. The n can be like integer only. Here, there is no point to say n can be integer, string, or anything, right? If your logic inside works, it can take anything. But there is no constraint. Whereas now you are telling that it should be like a constraint. It can help us. And what is the result? It is an iterator. So iterator of so int. So that's what with this. if there is any difference, it will try to help us. So means the static code analysis will be much more stringent to help us. So let's see back to the code. Assume that you have one file. So this is how you need to do. At the very first thing, we need to install this module. So pip install when it can work. Sometimes pip is not working. So then you do python -m pip. So like that. It is installing. It is saying that it is already installed. So it is having a old version. It is trying to upgrade it. So that's the beauty of writing -w. Means if it is installed, so then upgrade it. If it is not installed, then install it. So if you have any file, we can work with it. Say like in this particular file, I'm writing some code. So first I will try to see like, so there is some module called as the typing. Earlier we used to install it, but I think in 3.6 or 7 they added. So we need not do. And also one more point. Sometimes when you're executing, especially in Windows, you get this error. Means like what? OS permissions you don't have. When you are installing your Python, if you didn't give all permissions, it cannot modify it. So that's the reason I do like this hyphen user. If I do hyphen user, it is telling that install and do this only for this current user. Then you don't need that OS level permissions, etc. So whenever you get this error, don't worry. So your installations will work, but you need to do for user. So, but if you are using within a virtual environment, all these things are not needed, which I will tell afterwards. But what is this I wrote here is that first I'm using a module called as typing. In this module, there are different attributes. Instead of doing a print, I'm looping out this dir, I'm printing them. So it's a very simple program. So where we can see. So Python. So a type. Oh, I think I'm in the wrong directory. Okay. So Python a so and so. It is giving the list of attributes. If you can focus here, there were good number of attributes. So if you see the abstract methods, asserts, never, so many things are there. So means there are quite good number of things which it can help us. So let's see one real world example, how we can work earlier and how it will help save the things. So if I go for first example, so you see traditionally how we have worked. Traditionally, if you see, so we have a function, which is like printing a result. We do a hello world. That is how it executes, right? Python, say B so and so. It executes. The same hello world, I can add typing also. And observe carefully this function, this def hello. Same thing I will write. Say like def hello. Is it taking any argument? No. But is it returning anything? No. If it is not any written anything, what is the default return for any function? None. So we should write this arrow. And what is the return we need to write? If there is nothing, you write a none and write that print statement. Same hello world I have. Now, if I say like hello, execute again, it works. So if you execute, it works perfectly. So if there is no much difference. Direct executions, whether you write typing or not, it makes no difference. But how do you test it, sir? If you want to test it, so we need to use the MyPy. If you use MyPy, then we can test. So what is saying? From Python 3 onwards, MyPy is like built in. You need not even import. It is saying. But fine. So if I do like Python -m, so the script.py. This is how we execute. Means Python -m MyPy. So B example. If I execute, if there is any issue, it will throw an error. If there is no issue, it will be fine. You see, it executed. So initially, for the first time, I think it is taking the cache to build, but subsequently it would be fast. It is taking a moment. So I'm saying what? Name hello already defined. Did you observe carefully? So there are two issues. There is no issue with the types, but the issue is with the hello. The hello, it is saying that you define twice within the same function. This is also not good, right? So that also it evaluated. Maybe this time if I write hello to, and if I execute again, did you see? Now successful, no issues found. Means there are certain issues which traditional things, executions will not have any problem, but these will find and it will be, so that we need to be aware of. So next, if I go further, so the next example, this time types with some returns, maybe like I will take one more type. So this time you see now. So it is like something like this. You can see I wrote an ordinary function which is returning, but this time it is taking one input. So when it is taking an input, I can take like string. So if I take like a string, it works. And this time to ensure that both are different, I wrote like hello and hello one. So now if I execute Python hyphen, so Python hyphen m, so mypy and like C example. If you see, it is saying that, hey, so argument one for hello is incompatible types integer. Did you see where it threw an error? So in line 22. So means here you define that you will pass as a string only, but when you directly passed as a string, it worked. Here, as you passed an integer, it is throwing an error. But if I directly execute, will it work? Exactly. So direct execution will not have any issue. But this is kind of a linter which will help us to identify any runtime errors. So if you see now, so definition is good, but when you are executing, you are passing it. Fortunately or unfortunately, this input is also taking, because converting anything to string, right? It can convert anything. So that is what we understand. And if I comment this one, if I execute it, so now it will be perfect. What is saying? No issues, everything is working perfect, right? So next, if I go further to the next one, if I have like example, this time you focus on say, see this time. So I have a hello world which is taking an input and it is returning also this time. You see, I taken as a string and it is a returning string, so that's why I returned a string. So I am taking as an input and I'm returning. Perfect. If I do like a Python D example, it worked perfectly. In the same fashion, Python hyphen m, so mypy D so and so. So there is one error. What is the error? It is saying, hey, this function hello is defined twice. So we know, right? So we should not define it twice. So maybe like I do hello to, hello to. Wherever it found a potential issue, because Python has the concept of function overwriting. When you have two functions defined, so twice, one of them will be lost. To avoid that kind of problems, we can do like this. Hope it's fine. So next, if I go further to one more step ahead, say if I go for like one more example, so observe this. So traditionally, I have taken a function which is an input one thing, and I'm converting anything to a string. So this time in this process, I want to take any input. Earlier, when I took different inputs in a function call, it threw an error. But here the use case is that whatever you give, it need to convert like to a string. Just imagine real world, you construct a commands basically. When you're doing automations, you take like the server name, so number of servers, all the information, and you create a single command and execute that command. If you want to do like that, you see that we need to take another thing from typing import any. Means any data type should be taken and it should work. So when you are executing directly, it will not throw any error. At the same time, hyphen m. So mypy. So e example. If I execute, so only error is like what? It is taking like so the same name. If I take like mirror 2, it works perfectly. Mirror 2, it works perfectly. See, no issues anymore. So that is how it works. Next, after this, if you want to work with iterators, generators, all these things you can try on your own. If I go with like a iterators, in the iterators concept, the same thing. Whenever you have a function, we need to pass the values. So using dynamic typing, so ordinarily, I don't say it is a static typing with static added. So generally we have like input is I, so number we are taking, and we are returning. Instead of return, for the first time you're doing an yield. This is where you'll get a confusion. When you are yielding, you can yield a integer or a float or anything, right? So that's what. As I'm passing integer as an input, and I'm returning an iterator. What iterator? Iterator of integer, right? I'm returning. Sometimes we can return a string also, iterate string, etc. So within braces, we need to write that. So I am each time giving one value, saying that iterator of the one value is like an integer. So now it works perfectly. So Python f so and so. It worked. Python hyphen m my py. So f so and so. It worked perfectly for both. So this is how when we are working with iterators. So fine. Next, one more example we have is about, yeah. So we can have like many things like this in terms of type aliases and all these things. But the most important things I will touch here now. Yeah. So there are like many types like int, floats, dicts, and others. Whenever you're going for different things, you need to use. You see now, I just defined one variable. My data is equal to like this. Instead of defining, till now we are with functions fine. Ordinary variables if I am defining and using. So what it is a tuple of three values, which is like one is a string, integer, and a float. Then you see, when I'm defining, I'm writing after every variable, colon, and what is that? It is a combination, right? I wrote like this. If I say Python hyphen m, so my py g so and so, it works. So what is the error it is saying? My data is already used. So maybe like I will define like my data too. So except that, so others are not an issue, right? Earlier, this was not part. So the same variable. Now in the latest, so typing, they added this also as an thing. And similarly, if I want to work with one more example, you say this time, I have numbers is equal to like this. So whenever I want to define this, traditionally you write numbers equal to like this, as we know. So whereas here in the second case, what we need to write, numbers is equal to list of numbers like that and get the value. You see, as it's a list of integers, I'm writing like list of integers. So now it works perfect. And in the same fashion, if I go for a name tuples or anything, I can go in these lines. So you can give a try of remaining values. I will quickly glance to them. So if you have a combination of very complex data type, so you see here, list of tuple of float of float. So I have like a complex thing. Instead of defining every time, you can assign into an alias variable and you can use that. It's a list of tuples of float comma float, right? So that kind of complex thing. So nothing is complex if you can understand it. So it is a dictionary of key is a string, value is an integer. Key is a string, value is an integer. What if value is a list? Again, you write a list of so and so. So here in this case, key is a thing. So list of dictionaries. List of dictionaries. So at the same time, so you can have many things like this. So like this, you can go. And lastly, if you want to work on any of the literals or anything, yeah, union types, yeah, this is one thing. If you know, you can work. So if you have like multiple data types, sometimes it would be a case like you can have any of the things. So in that case, we can go for this example. It would be really helpful. You see, union of boolean and string. So means, so you are taking a number. Sometimes you will return a string. Sometimes you will return a boolean. Means whenever you have an error, you return a string. In other case, you write true or false. So in that case, we should say union of. Sometimes when you have a input also like that, you write a union of. So in this case, it can result a true or a false or a string. So to facilitate both, I gave like this. In the same case here, exception you are getting. Sometimes it's not error message, but exception. In that case, boolean comma exception. So any of these two can come. So that's what I facilitated. If you say Python hyphen m, so my py, so case on. So it works perfectly. So what is the error now? What is saying? So item bull of will has no attribute args. So it has no attribute args means so union of two values you are passing. So has no attribute args means like you are passing two values. You need to place like comma separated. So in the first case, you are passing like a boolean of this thing and this. Like that we need to go. So not going too much into it. So next, going to the next one, which is like a doc test. So till now, for the code enhancement, you added all these things to help yourself. Next one is like into the uh, doc test. So 03 doc test. So doc test means documentation test. By the name itself, it is telling that. So if you want to work with the doc test, first we should understand this documentation and tests. So till now I told you, if you want to work on documentation, you need to work on PyDoc. I told. PyDoc is for creating documentation. But if you want to validate a documentation, you need to have PyDoc, so this documentation tool. So what is this documentation tool? How it can help us? Let's see. So this PyDoc by default will be there. And if you want to add, you can do it. So if I'm going for one of the example. So generally when you write code, we write all the edge cases and execute it. Say if I have some code like this, you see. Generally, when you have code, no one will write a doctest.test mod internal to the code because you don't want your production code to have all these things. But you will write a test like this, right? So sometimes you will write a documentation. Within the documentation, you write what is the usage. Just imagine if I don't have this line for a moment, I will execute this one only. So how do you execute this code? So I can, prompt hyphen, so I can remove it. So I can navigate to the 14 directory cd 03. So I can simply ask Python a example. Like this, I can execute, right? So I will get the result. But if I do like a hyphen I when you are executing, means after executing, it will go to the interactive mode. Then I can ask each of the squares. So first, whenever I want to create a documentation, this is how I create it. So first I execute that function. So if I give like a -9, what is the result? If I give like, so 0.09 or something 0.09, what is the result? So what are the results I'm getting? So I will try to paste it as it is. So now I got like an extra result, right? This extra result, I am placing it here. You see, I need to write like this. This operator is called as chevron. Remember that. So now I want to evaluate whether it is correct or not. Either within the code we can evaluate, outside also we can evaluate. Within the code, if you want to use, first we need to import the doc test and write like test mode. And if you directly execute also, it will execute that and evaluate. So test mode, it is executing in the backend for us. So if you do like this also, it will evaluate. If there is any issue, it will throw an error. If everything is good, fine. Sir, if I am writing like 810 for one of them, and if I execute it, now did you see it throw an error? What it is saying, hey, I executed this test called as square of 9 -9. I expected 810, but I got 81. Now did you see? Anything if you do a mistake, so it will throw an error there itself. Such that whenever you are writing a documentation, you will write like perfect document. In the same fashion, let me go for one more example. So within this, if I say I have one more example. You see in this example, so add two numbers are there. It is taking two numbers and giving a result of 46. So whatsoever you have, so that also you can check. So if I say like Python, directly B execution, because we are taking doc test inside itself, doc test mod. But in fact, in real time, we don't do like this. So, but if you change any of that, say like something else you give, it will throw an error. So that we are pretty much aware. Next, if you in this particular case, sometimes when you're executing, we cannot predict the exact answer because sometimes the users can give the real-time values, so user input values. In that case, how do you predict? So how to check? So for that, we need to go for an Eclipse operator. You see, in this particular function, we have a default argument called as world. If the user gives world, it will take like hello world. But so if the user don't give, so it will say hello world. But if user gives something, you will get it. So if I want to check like this, so this is like standard check first time. So this is also standard check. But this time what I'm saying, 3 dots. This is called as Eclipse operator. Means like instead of test mode, I'm passing like optional flags. Means if you get like 3 dots also, evaluate it. Means what you are expected, hello should be there. After that white space, and you can get anything. You are not considering about what it is coming. So in that case, you can execute like this. You see, like test mode, we can also pass optional flags and others. So this is also part of your CI/CD process itself. You do the testing of this documentation also. So next, if I go further, so like one practical example to say real world, you can have this example. Okay, see here. So I have like area of so and so, area of square, area of circle. So I have like, so 16 digits precision it can get. So be aware of it. Whenever you are giving a number, you should ensure till 16 digit. Whatever it is giving till that 16 digits, it can get it. So be aware of that one point. So next, last point within this function is like this doc test can be executed from outside also or like inside also. So till now, I'm showing this one outside execution. In the same fashion, I can show outside also. Means like we need to have a separate function for that. One second. Okay. Yeah. So even in this example also, I can do the same thing. See now, I have some executions. I have these optional flags, all these things. So either I can execute like this, Python -e so and so, like this also it evaluates. At the same time, if I don't comment, I don't want it. So to be executed, I will comment it. So I will do like Python -m doc test. So this is so and so. It will evaluate like this. If there is any issue, it will throw an error. If I write something else, nonsense, so it will check that. See, I wrote a nonsense, right? It is throwing an error. So if I write like 4, it works. So, so like this also you can execute and evaluate something. Within the code also we can evaluate. So we need to know. So the assignment for you is that what if you are getting a generator? For generators, so check for generators. So how the generators will work. So there how you need to change the things, how it will work, that kind of thing you check for a generators. Okay. So this is the assignment for you. And now we are finally jumping to the most important thing, which is unit testing. Anywhere if you say code quality, that is the paramount importance is unit testing. I intentionally didn't test unit testing till now because there is a reason. So unit testing, there is a process. For unit testing means when you are writing a code, you need to test it. There is a module called as unit test also. Don't confuse with that. Unit testing is a process. Every language will have. When you're writing code, you want to check whether unit level everything is working or not. The very first thing about unit testing is, if you remember, we already worked on something called as asserts. So, using asserts also we can do the unit testing. If I can start with these asserts, the simple examples. Hope you remember. So we have worked on asserts till now a lot. So if I can focus on these asserts, say any assert will have the standard syntax like this. So assert, what are the statement? If that statement is not correct, what is the message to come? So like that we have. So till now, why we go for asserts I told. In real time, we cannot write a print statement every time and check whether something is true or false. It's very difficult. So, but we can check. So using this one, say CLS and Python, so and so. If I do like a print statements, yes, 2 plus 3 is equal to 5 means it will give a true. But we cannot see the script every time, right? Whether everything is getting correct or not. You want to execute, if something is correct, not correct, you want to stop there. So that's where you can write like an assert. If assert, you can write like a simple statement, or apart from statement, you can write some message. If still the statement is correct, nothing will happen. It will just execute. But if there is an issue, use case 2, if I go, in this case, 2 plus 3 is equal to 6, I'm saying. 2 plus 3 is not equal to 6, right? It is false. If you do the same thing with asserts, then it's gonna throw an assert error. So every assert like this, it will throw an assertion error, and you get the result like this. So similarly, if I go for one more assertion, so for every assertion, you will get an error. If I say 10 minus 34, it is not greater than 3. So whatever the error is, you get it. Did you see in this case, you got an assertion error, but you didn't get the error message because I didn't get it. So if I say like incorrect, so I get like incorrect. You see incorrect. If I don't write anything, I don't get anything. So that you should be aware. So if I, yeah. So if this time if I add something, it works perfect. So now we need to understand that any statements, if you want to do, you can check like this. You write an assert, and if it is not correct, it will throw error there itself. If it is correct, everything will be fine. But sir, so these asserts we cannot handle, because for every time we need to have a try exception. It was big difficult, right? So we need to have a framework which can handle all the exceptions and give us like in one place systematically. So in that case, we need to go for a next module. But before that, a couple of other examples we will see. You see, in this case, this is one thing I forgot to tell you. So what it is saying, this is like 3 data types. Earlier, we don't have the concept of like multiple things to go. So union was not introduced. At the time, people used to go with like pipe only. So this is also a way, that is also a way. If you want like either int or a string or a float, anything can be there. Here also it can be int or a string or a float. So that to make that, so typing it is like this. And we have some statements to check. If everything is correct, it will be good. If there is any issue, it will throw an error. So like that, different kinds of asserts are there. Now going further, like these asserts, we have another thing called as unit test module. So this is most important because individually we cannot handle all the assets. We should have a framework to better handle these assertions because we cannot write every time like so multiple try exceptions. So observe there is a module name itself is called as unit test. So this is a process. So unit testing. For that in Python, they created a module itself is called as a unit test. So that's why I'm writing like unit test module. So unit test module. Remember like that. Using unit test module, first you need to know how to write the unit tests. So first, if I can focus, maybe like I will copy this path and open again here. So open a folder so that you will focus only on those things instead of a big folder. So you will focus there. So first, in terms of unit tests, first if I say unit tests. First, in terms of unit tests, first example, if I say, till now, whatever we have done with a asserts, that slightly we will modify. So first to understand that, we have something called as unit test module. So if you ask for the dir, it has good number of attributes, in fact. So see, so when I open this subdirectory as a path, I can directly work on it. So I can navigate to this directory. So Python, a so and so. So now the code is more clean, right? You are focusing on what chapter you are working. So unit testing. So these are the list of attributes. And also, if you are aware, so we have the help statement. Help is the only function which don't need a print to print in the console. You see, so about unit testing framework, it was developed in accordance with the JUnit of the Java. So and like small tag frameworks. So based upon that, they have developed this. So I told you, whenever you are doing a help, if you write a queue, it will stop the help there. So these two things you are aware. Now coming to the case. So till now, what we know, the very basic things are print statements and asserts. I told the problem with this. Print every time we cannot see. Asserts means if everything is good, fine. If there is a problem, it will stop. For one, if there are 10 or 100 unit tests, if it stops for everyone, it would be difficult, right? If it can list out all issues at the end, like a commonly, it would be great. So for doing that kind of thing, so here we need to go for something called as say class. So for testing, say like test edition is my class. So I need to inherit test dot test case. This is most important. So if you if you inherit it, then we can work on it. So here in the unit test, where this is like a class, within this class, if you want, you need to write the test cases. It's like every method is a test. So if you want some test case to be run, so we need to write. So earlier we used to write like assert statement. Now instead of assert equal to, I write assert equal. So this result and this result should be equal, right? I wrote it. It's like one test. So if I execute this, you see now, if I execute it, Python a so and so. The first one was executed. This one was executed or not? No. How do you how it will be executing? So means like Python hyphen m unit test. If I do within this directory, all things are there. It will check. At this moment, it has only thing. So if I say like yes or no, like specific script also I can ask. In this script, one was ran. So one test case is there, right? This is like a suit. Within that, whatever you have, that is a test case. So that is about it. Similarly, if you have some other use cases, say like I have some asserts like this, true and a false and others. So if I want to check different kinds of cases, I can write another unit test also. Maybe right, I will write one more unit test. So test case dot so and so, I want to check it. Now if I say, if I execute it, did you see two test cases were executed? But you don't know which test cases were executed, right? You can write hyphen v actually. Hyphen v means verbose. You see the test add positive. This is part of the first suit. So part of the first suit, it is okay, means perfect. Similarly, test booleans. No, these are not mentioning the class names, right? Means classes are suits. Within that, functions are the methods are the actual test cases. So if I have like one more test case, say like I am adding one more thing, asset equal, asset not equal, like that I can write. Now if I see, if I execute hyphen w, now three test cases were executed. More verbose. So you got all results. Similarly, if you want to execute them within code also, we can write like this. So if you want within the logic to execute, we need to write unit test dot so and so. If you now, if I say like Python, so directly the script, so like that also it will execute. So I gave like verbosity level and others. So now what you need to understand is like this, there were many assertions. So in real time, not every time you will check equal, right? Sometimes you will check less than or equal to different cases. For that, these people have made ready-madely. That is the beauty of any framework, right? So unit test is a module which handle these assertions in a better way. It's not just like equals or not equals, whether something is true or a false, or is means objects are equal or not. In operator, membership check, greater than, less than, or regular expression checks you can do. Counts almost equal. This is most important whenever you're working with the decimals, right? So and like the dict equal, list equal, set equal, and similarly whether you get a warning or exception, all those things you can check. So these are like different options we have. So to check. So like this, any executions will execute. And the last point, so before stopping is about the execution order of this test. Whenever you are writing the test, we should be aware that this test will execute in the alphabetical order. If you see, so till now we have tests. So test two strings, test booleans, all then test two additions. These are three things I have. If I execute this one, I can directly execute Python -m unit test -v I can give, and specifically if I give the script. Now did you see? It is executing. test add positive was executed first. Though you define these cases first, test two strings is first. It executed test add positive. Why? Because alphabetical order. Though you have three, first it will sort them in alphabetical order and it will give. It doesn't matter what is the suit name. Suit name can be anything, but tests will go as per the methods only. So like that it will go. But if you want to add any specific order to this, so it's better to write a numbering. So that's one thing I would suggest. So, and lastly, within the test, if you want, so you can add like the asserts in a better way. So like writing like this. There is no specific limit that how many methods you want to do. And in one